linear momentum. So in other words, when the net external force acting on the system is 0, or else is called an isolated system, the total momentum of the system is constant. So maksudnya jika awak ada bola A langgar dengan bola B, bergerak, bertembung, tak ada orang datang tiba-tiba pergi tolaklah bola B, that is called as isolated system. Total momentum sebelum kena sama dengan selepas. So dia punya condition is it has to be an isolated system. Okay, then we have collisions. Collisions is an isolated event, as I said, tak ada external forces, which two or more bodies exert relatively strong forces on each other for a relatively short time. Basically berlaku pelanggaran lah, sama ada dua objek ataupun lebih. So we have two types of collision, sama ada elastic ataupun inelastic. So for elastic collision, so this is not like high school lah. Kita tak simply kata oh bila objek berlanggar they are colliding with each other then they stick together, that is elastic. Macam tu tak. So kita kena tengoklah dia punya condition. If the for both collision, total momentum has to be conserved. Sebelum kena sama dengan selepas, sama ada elastic atau tak, tu adalah syarat utama. Tetapi for elastic collision, the total energy is conserved. Maksudnya kinetic energy initial sama dengan kinetic energy final. So kinetic energy ni formula dia apa? Half mv square. Kalau inelastic pula, total kinetic energy is not conserved. So when you calculate kinetic energy awal tak sama dengan akhir, so we know it that is inelastic. Kalau soalan tanya state the type of collision, tak boleh jadi tok bumbung untuk teka-teka ke, kena buat calculation. Calculate the kinetic energy initial, calculate kinetic energy final, then compare. So inilah kat sini. Okay, so kita tengok example. So kita ada car A and B, given that they are moving directly to each other at the same speed. So UA sama dengan 10.6, UB is 10.6 juga, cuma sebab UB is moving to the left, so it's negative 10.6, and finally they will collide. Right after the collision, car A bounces backwards. So car A dan langgar, lepas tu dia patah balik. So VA is 8.4, cuma sebab dia to the left is negative 8.4. So kita nak VB, kita tak tahu, given that the mass car A is 250 kg, mass of B is 260 kg. So we need to calculate the final velocity of the car B. So bila kita nak calculate, kita first kena tulis konsep lah. P initial sama dengan P final. So MA UA plus MB UB equals to MA VA plus MB VB. So it's 250 10.6 260 negative 10.6 250 negative 8.4 plus 260 VB. So VB ni awak dapat 7.7 ms negative 1. So because this final velocity kena datang dengan direction, because you get the positive answer as our assumption before. Kalau ke kanan positif, ke kiri negatif. So when we get positive answer means it is to the right. Okay. So for question B, what is the type of the collision? As I said before, kalau ada tanya type of collision ni, awak kena calculate lah kinetic energy initial dia berapa. So 1/2 MA VA UA 1.6 square plus MSB 260 negative 10.6 square. So dapat 2.861 10 sekejap 1, 2, 3, 4 10 to a 4 joule. Energy final 1/2 mass 250 with 8.4 square plus 1/2 260 7.7 square. So kinetic energy final awak dapat 1.6527 10 to the power of 4 joule. So that you see that value of kinetic energy initial tak sama dengan final. So kinetic energy initial tak sama dengan kinetic energy final, therefore it is in elastic collision. Okay. So next, yang ini bila kita ada sudut lah. Okay, maksudnya this 2 dimension. So we have a tennis ball M1 250 gram So this is 0.25 kg. Initial velocity U1 is 20 meter per second. Kalau is soccer ball of a mass of 900 gram, so mass 2 M2 is 0.9 kg. Initial area, so U2 is equal to 0. Okay, after the collision, the tennis ball is deflected 50 degree from its initial direction with velocity 4 meter per second. So this is V1 74 ms -1. M1 awak sama lagi lah 0.25 kg. Determine and sketch the velocity of the soccer ball after the collision. Okay, so kalau awak tengok yang ini, kita kena ni X ni X component, kita kena pecahkan X dengan Y component. Kita buat table lah. So before collision, X component awak yang ini sahaja, Y component awak akan kosong lah, sebab pelanggaran awak berlaku pada X axis sahaja. So this is M1 U1X. So basically untuk ni adalah M1 U1X plus M2 U2X. Okay, so M1 U1X which is 20 plus 0 lah, sebab U2X awak kosong, Y component awak kosong lah. Okay, then final collision in X component ni kita kena tarik ke sini. Okay, so it is M1 V1X plus M2 V2X. So 0.25 times 4 cos 50 plus 0.9 V2X. So this is Y component M1 V1Y plus M2 V2Y. So M1 is 0.25, V1Y is negative 4 sin 50. Kenapa negatif? Sebab bila kita tarik this one ke bawah, dia punya direction dia akan pointed downwards lah. So M2 is 0.9 V2Y. Okay, so kita nak velocity, so maksudnya kita cari V2X and V2Y macam chapter 2 lah. So kita guna apa ni? So summation P initial X sama dengan summation P final X. Ni adalah conservation momentum lah. So 0.25 times 20 equal to 0.25 for cos 50 plus 0.9 times V2X. So V2X awak ni akan dapat 4.84 ms -1. Then sebab kat atas P initial Y equal to P final Y. 0 equal to 0.25 -4 sin 50 plus 0.9 times V2Y. So V2Y awak ni akan dapat 0.851 ms -1. So magnitude of V2X 4.84 square, V2Y 0.51 square. So V2 dapat 4.91 ms -1. Sekarang kita kena ada theta. Sorry tak muat lah. So theta awak adalah shiftan V2Y 0.851 divided by 4.84. So dapat theta is equal to 9.97 degree. So kita tengok, so ni V2Y positive above positive X axis. So bila kita nak sketch tu, so start tempat lah kita tak punya So bila kita sketch, this is you punya V2 V2X V2Y. So this here will be 9.97 degree. So that is about it.